record. We're going to actually have our lesson now. We were talking about the this keyword today. So if we remember back to last class, when we have two variables in the same scope with the same name, the variable with the more specific scope is going to take precedence. It will overshadow the one with the more general scope. It will overshadow the more general one. So here, my number in my print number method will overshadow my instance variable number, which means I will print 10 instead of 0 here. The same thing happens if I try to, in my constructors, have my instance variables have the same name as my formal parameters. So let's look at this example. I have my width and height as my instance variables. I have my constructor with width and height as my parameters, saying width equals width, height equals height. So if I make a new rectangle, since my width and height are being overshadowed, my actual instance variables are both being initialized to 0. So if I print out my width here, I'll see 3 because that's the parameter that's passed in. So 3 gets passed into this value. But then I'm saying that variable, width equals width, and height equals height. So I'm not actually referencing my instance variables. So those are going to be staying at 0. It's going to be initialized to 0 just by default because that's how classes work. So both of those are going to be 0. So when I try to access my width and height from toString, that width and that height, which never got touched inside of my constructor, are both going to stay 0. Now, there is a way to fix this without changing the names of my parameters. We can solve that shadowing problem by using the this keyword. So when we're using a non-static method, when we're in a method from an instance, the this keyword is going to refer to the object on which the method or constructor was called. So we can reference our instance variables or our methods within the object we're calling stuff on using the this dot whatever notation. So if I make a slight change to my naming or to my code from before, if I say this dot width equals width and this dot height equals height, now that width and height value, we're going to correctly pass those in. And since we're saying that this dot here, that's referencing this width is here and this height is here. We're referencing those instance variables very specifically rather than just saying width and height. So we're saying from the current object that we're in, I want to access its instance variables. Just like if I got an object of a different, another object of the rectangle class in a method, I could say other dot width, other dot height. Here we're referencing the current object. We're referencing this. And this is really just, it's helpful for clarity's sake. It helps us to identify things when we are referencing our own object. Now we can also use the this keyword to call methods from within the same object if we want to add some extra clarity. So if I have a method called getArea and a method called hasGreaterArea, which takes another rectangle as a parameter, I can call the this.getArea and the other.getArea, compare them, return whether one is greater than the other. Where within getArea we are calling this.width and this.height. We're accessing the instance variables. Lights. Accessing the instance variables from this object specifically. We're being very explicit about which object we are referencing. Does that make sense? How this works?
Is it kind of like self in Python?
It's like self in Python, yes. So we're making sure to reference the object that we're currently looking at, so that it's mostly for clarity's sake. So if I call these methods from my rectangle objects, if I have rectangle R1, rectangle R2, and I have a Boolean greater equals R1 dot has greater area R2, I can print rectangle 1 does, and if greater is false, we'll say not. If it's not greater, if it's not false, we're not going to say not. And then have greater area than rectangle 2. So R1 here is going to be the same object referenced in that this. So we can, it is really there to help us ensure we know exactly which methods, which variables we are trying to access when we are accessing variables within a method in a class. We can even pass this to methods as a parameter. So let's say we change our get area slightly so that it gets a rectangle as a parameter, and we change our get area to pass this and other to our get area instead of calling it on each of those individually. So we call get area with this object. We pass our rectangle, whether it's this or other, and we'll return that rectangle with times that rectangle's height. So no matter which rectangle we pass, we're going to get its area. And we can just use this as a parameter here because it is a variable in and of itself. Still referring to the object we're still working with. So let's write a method for our superhero class. Remember back to the beginning of this unit, we talked about making a superhero class. Let's compare the power or the strength of one superhero's power to another. Let's make sure that we know whether one superhero is stronger than someone else. So this is our basic implementation for our two classes. We've got our superhero with a name and a power. A power has a name and a strength. And both those classes are going to have accessors and mutators. So if we want to write our isStronger method, what will our signature look like? What type of value are we going to be returning from isStronger? A Boolean, correct. So we're going to have a public method. Our methods are usually going to be public. We're going to return a Boolean. And then isStronger. And we're going to have a superhero as a parameter. So we can compare the other superhero with this superhero. We can get the strength of our current objects using our this object, this dot power. We're accessing our power instance variable, and we're going to call get strength from that. So we can store what the strength of our current object is. And let's say we have a get power method built into the superhero class. Sidetrack. We are able to use dot operators one after the other. We can stack them to access values within things that we're accessing. So from this dot power, I am accessing the get strength method. I'm stacking those dot operations one after the other. So if I have a method called get power to return the instance variable of power of a superhero, I can call that. Once again, I am stacking those dot operations. So we're returning the power of our other superhero, and then we're getting the strength from that power. Now, since other is a superhero, and we're building this method in the superhero class, we don't need to actually call that accessor. Any variable of the same class type we are working in, we can access its private variables without needing to call accessors. And we learned this in a previous lesson. We can access private instance variables as long as we are in the same class as that object is made of. So we're in the superhero class, so we can access this superhero object's private instance variables. Now, we cannot do that with the strength instance variable here, because strength is private to the power class, not the superhero class. So we still need to call that getStrength method to get the strength of the other superhero's power. Our last step, we need to compare those strengths and return true or false. So we're going to return whether my strength is greater than their strength. So if that's true, we'll return true. If it's false, we will return false. There we go. Now, we actually don't need to have each of those be their own variable. We can shorten that method by having the calls to get the strengths directly within our comparison. We don't need to make separate variables. We can say return this.power.getStrength greater than other.power.getStrength. Because if we don't make extra variables, we're not going to be wasting any extra memory. So this saves us a bit of space in our computer's memory. All right, does the this keyword make sense? How and why we want to use it? Cool, okay.